Good evening, everyone. Mechanics of Materials, Chapter 5, Torsion. Let's review an example which consists of a solid circular cantilever shaft handling both continuous torsional torque, a uniform continuous torsional torque, plus a single torque like this reddish T applied at a distance of a quarter of L. In this example, we want to calculate the rotation at the free end of the beam. So in this problem, we do have a solid circular cantilever shaft with both a uniform continuous torsional torque plus a, a single torsion at a length of L, a quarter of L. Let's see how we can solve such problem. Let's flash back to axial force in a beam configuration. For example, if all the distances are provided and P is applied here, you can flip it like 90 degrees and convert this beam to this one. And all these distances are one third of L. So it just make it like L over 3, L over 3, and then RA. If you want to calculate RA, share of reaction A is definitely bigger than share of reaction at the D because it just has a farther distance. So one can say if this is A, this is B, one can say RA is B over L times P and RD is A over L times P. So in here, B is 2/3 of length and this is 1/3 of L. So definitely RA is 2/3 of force, 2/3 of P, and this is 2/3 of force as well, because that's 2/3 of L over L times P. L and L cancel out from numerator and denominator, and you will have just such relation. You can have the same analogy for torsional torque. So if you have a two fixed support shaft and a torsional torque applies at L over third from A and 2L over third from B, definitely share of A is bigger, and that's 2/3 of, these are T, because that's 2/3 of L over L times T, and this is 1/3 of T, because that's 1/3 of L over L times T. L and L is canceling out. Like here, these are also, my bad, I have to modify it here as well. So the same story happens in torsional torque. So by this information, we can approach our problem. I had it like here. It's just only the top. By this analogy, so we can jump to our problem. If it was only a single torsional torque, phi at B was TL over GJ. So just assume there is no continuous, and in that sense, phi B due to this one is just, let's first do it this way. First, we assume that phi B is equal to 0. First, we just consider the other side as a support. If phi B, and then calculate TB, and just assume there is no nothing here, just this single shaft. In that case, TB was a 1/3 of, my bad, 1/4 of L over 4 over L times T. So that makes it 1/4 of a this one. So we have already handled this part. And then, because in reality phi B is not 0, so phi B is TL over GJ. In that case, we can handle this one and then solve our problem. So in such sense, if we just convert this one T times L over 3, and the distance is at the center, so that's L over 6. L over 6 plus L over 3, it's equal to 6, 1 plus 2, that's 1, a half of b. That's the distance over here. So now we convert this uniformly distributed torsional torque to a one single torsion, and we had another one. So in that sense, TB is a combination of this one and reddish and yellowish one. This is TL over 4 times L, and the other one is T times L over 3 times L over 2 distance over L. It makes a quarter of T plus a 1/6 of T. And if you add it up together, it just gives us a TB is equal to 5T over 12. That's our TB. And then from TB, if you just replace it in phi you can easily calculate that phi is just TB times L over GJ. If you replace TB in this equation, you can easily get phi is equal to 5TL over 2GJ. You can also solve this problem in a more conventional method by integration. So second solution is like phi integrate for the continuous part from L over 3 from here to 2L over 3. That's the limit of our integration. Then Tx dx over Gj plus the other part, which is a single torque TL over Gj, TL over 4 over Gj. So it just make it like this is our constant, and this is our integration Tx squared 2Gj from L over 3 to 2L over 3. If you do the math for integration, it just gives you the same numeric value, which gives you TLQ squared over 6GJ plus, again, you consider TL like capital T, that's a TL over 6GJ plus 1/4 of TL over GJ. It gives us 5 over 12 TL over 12GJ. That's our phi b. Thank you. We'll solve more problems.